Hi, welcome to MVPDays and my session on microservices. My name is Robert Corradini, a cloud and data center MVP, and I'm here to talk about microservices, and it's really an introduction to understand microservices on Azure and specifically on Service Fabric. Before we get started, a little bit about me. I'm actually the Director of Product Management at Five9 Software. As I said, I've been a Microsoft MVP in Cloud and Data Center. I'm also an MCSE, CCNA, CISSP, etc. You can also check out my blog where I'm constantly writing around a lot of Microsoft-related topics. And also you can catch me on Twitter for a lot of real-time activities and social engagement, etc. What's the agenda today? Today's agenda is really, we're going to talk about the microservices overview and really understand what is a microservice. Then we're going to quickly jump into scenarios. Then after that, we're going to talk about reference architecture. And then we'll talk about monitoring and troubleshooting. And then decision guidance. If we do have a little bit of time, I'll go through a little bit of frequently asked questions. So let's actually get started. Sit back, hang tight, and enjoy the ride. What is a microservice? The definition of a microservice is applications that are composed of small, independently versioned, and scalable customer-focused services that communicate with each other over standard protocols with well-defined interfaces. What do we mean by that? Okay, so what are the characteristics around that? Well, we're encapsulating a very small atomic functionality, typically one specific function. It's developed by a small engineering team, so it gives you a lot of agility. It can be written in any language or framework. It contains code plus state. It interacts with other microservices over well-defined interfaces, protocols like HTTP. It also has a unique URL that can be resolved, and it remains consistent and available in the persistence of failures. With microservices on Azure, let's talk about a little bit about scenario overviews. Why would you do it? So you would build, deploy, and operate independent services at scale. So it gives you the really ability to scale out that application. It also gives you rapidly integrate, evolving applications that have really rapid development cycles. Faster delivery of features, capabilities to respond to customer expectations because you have smaller groups dealing with one specific function. You also have improved resource utilization to reduce costs. Let's talk a little bit about the customer requirements. They want to be able to scale different parts of the application independently based on their needs. They want to, really empower their development teams to be more agile and roll out an application and service changes. They want to provide features to customers faster and even more frequently. They want improved resource utilization while reducing all costs. They also want to hide the complexity of IT or infrastructure and really increase that abstraction layer. And they also want to provide that rapid elasticity based on the business growth. And that means scaling out and scaling back. What's the solution? Service Fabric on Azure. And it represents really the next generation of middleware platform for building out and managing these enterprise class tier 1 cloud scale applications. It really simplifies microservices-based application development and lifecycle management. It delivers low latency performance and efficiency at a massive scale. It runs in Azure, on-premise, or even in other clouds. It's a proven platform used by Azure and other microservices, which we'll talk about a little bit later. And it was born really from years of experience at Microsoft delivering mission-critical cloud services. Modernization with microservices. What we're looking at here is essentially a microservices platform. So typically you would have, you have an HTTP listener, a page content, authentication, and then you'd have some business logic underneath it, order management, reporting, and then obviously you have your data, which is product inventory and a customer database. These were individually built and deployed. They were very small, independent atomic services. Because one is like HTTP listener and page content and then authentication. They integrate using a published API, finely grained and loosely coupled, which is really important. And if you compare, cloud services and Azure Service Fabric, they're definitely different characteristics. So typically when you're deploying an app or a worker role workload, You're basically doing one service instance per VM, and you also have a lot of uneven workloads. You also have lower compute density. There's also slower to deployment and upgrades. You also have slower in scaling and disaster recovery. It's involving apps, and especially apps that really rapid agility. This is where Service Fabric comes in. It does stateless, stateful, and actor services. It has many microservices per VM, so you're getting much more higher density in that VM. It's faster deployment and upgrades, and it also has faster scaling for microservices across the cluster. What's the comparison between application development approaches? The traditional monolithic app approach from the past is you essentially have the app on top, and it has all encompassing of everything, all those different functions, and then you have your data on the bottom. And you have the microservices approach where you're really separating all those functions, right? And then really distributing all those functions across many different planes. So what are different types of microservices? We have stateless microservices, which really either has no state or it can be retrieved from an external store. There can be N instances. So for example, web front ends, protocol gateways, Azure Cloud Services, these are all stateless microservices. So what is a stateful microservice? Well, a stateful microservice maintains hard authenticative state. It has consistent copies through replication and local persistence, and essentially stateful service would be like a database or documents or a workflow, user profile, shopping cart, etc. So what are the challenges of building your own microservices platform? You got a number of problems to solve. You have service availability, resource allocation, state management, versioning, independent upgradable services and data, and then obviously rollbacks. With microservices, you provide the design and code, and you can still write monolithic apps and do bad things. Microservices, again, diving a little bit more deeper into the definition. Applications that are connected by small services. Each server does one thing very well. It uses bonded contexts for data. Use versioned interfaces for services. Each service is easy to understand. And service lifecycle is owned by a small team. Benefits of this, where really, services are loosely coupled. Each service is independently deployed. Very important. Services have short development life cycles and agility. Stateless services replicated for availability. Stateful services partitioned for scale. Stateful services replicated for availability. And you have a lot of testability. So, problems and solutions. The typical problems with a monolithic app is, rolling upgrades, availability guarantees, scale out infrastructure, resource governance, density, policy enforcement, granular versioning, and so on, as you can see on the screen. What really is the solution is Service Fabric to really solve all those problems. In a nutshell, you can write once and then really run anywhere, whether you're running on Azure, or your own private cloud, or even a hosted cloud. What are some of the services that are built with on microservices and Service Fabric? So you can see some of them here, like Intune, which does inventory and software deployment, Skype for Business, Bing Cortana, Azure SQL Database, and they're obviously and Power BI, etc. So you can see there are a lot of stuff that's been using my Service Fabric for quite a long time. The application platform, and really, how do you position Service Fabric? So typically you're obviously hitting the app creators. So you have developers that you're talking to, and typically you're talking about their existing app investments, and understanding what they're doing with their app investments. Are they, they're built on IaaS? Are they doing a lot of lift and shift? Are they Docker? And what are the differentials, when you go from an existing app investment? And for example, you're going from, a custom monolithic 3-tier app to a custom microservices-based stateless or stateful solution. And then at that point, you're really evolving into a SaaS application. And then, and really from there, from a SaaS application, you really want to, understand that get into that really line of business application that gets more of a platform as a service. Again, for non-developers, there's a time to value because you have rapid development cycles with, again, essentially going the Service Fabric route and then moving on from there. Well, let's talk a little bit about Azure and its infrastructure worldwide. We're talking about hyperscale infrastructure really is the enabler. Azure really has 100 plus data centers across 36 regions, and it's actually a little bit more than that because this slide is probably a couple months old. A couple stats that are really important to understand is that it's one of the top 3 networks in the world. It's 2.5 times AWS, 7.5 times Google data center regions, and has the largest VM in the world, which is 32 cores, 448 gigs of RAM, and then SSD and whatever you can go up to at this point. It also has the largest VM in the world, 32 cores, 440 gigs of RAM, SSD, etc. The Continuum. So let's talk a little bit about this, where you're bringing your traditional monolithic 3-tier app all the way to really a PaaS application. That journey really starts with, where you're at. You have a pure IaaS application, and it's a 3-tier application. And what the next part of that journey is really going to unstructured PaaS, and that talks about containerization, technologies like Docker, etc. And then the next part of that journey is structured PaaS. This is where you really start using Service Fabric and building out those microservices. Really building out that Service Fabric on virtual machine scale sets. And then next part of that journey is really pure PaaS. And you really have an app service. A little bit of Microsoft, and this is a great slide. It shows where Service Fabric is in the grand scheme of things, which you can see is under App Platform. But this is all the services that Azure does provide that you can use as part of microservices deployment. So let's talk a little bit about scenarios. What are key application scenarios for Service Fabric? Well, high availability services. It really provides fast failover for creating multiple secondary service replicas. It has scalable services, so individual services can be partitioned, allowing for state to be scaled out across a cluster. Computation of non-static data. So it really Service Fabric enables you to build data, input, output, and computational intensive stateful applications. Session-based interactive applications. Service Fabric is also useful if you use those applications such as online gaming, instant messaging that really require low latency reads and writes. Distributed graph processing, the growth of social networks has greatly increased, really understanding these graphs in parallel. You need fast scaling and parallel load processing, and Service Fabric is really a natural platform for processing those large scale graphs. And data analytics and workflows. The fast reads and writes of Service Fabric really enable those applications that must reliably process events and streams of data. What are the different programming models? We have the traditional guest executables. You bring any exe, it's any language, any programming model, packages an application, it gets versioned, upgrade, monitoring, health, etc. And then now you talk about reliability services. Service Fabric, where you're getting into stateless and stateful services. You have concurrent and granular state. You have the use of reliable collections, transactions across collections. You have full platform integration, and you can use any communication stack. And then we're talking about reliable actors, where you get into stateless and stateful actor objects, simplified programming model, single threaded model, and it's really great for scale out, compute, and state. So let's take a look at some reference architecture. This is a traditional 3-tier architecture where you have stateless services, a SQL Server, or an Azure SQL DB, and then you have cache trying to help, like Redis cache. And as you can see here, you have a web tier, you have that services tier, you have that cache tier, and then obviously you have that data tier. And really, the main bottleneck of that is the caching tier. Sharding can help, but it's complex and it's not really a common approach. Data in that traditional approach is, you have a single monolithic database, tiers of specific technology. Caching doesn't help for really massive data ingress. Database servers are usually the bottleneck, Monolithic databases are shared across services traditionally. So what does it look like in a microservices approach? You have a graph of interconnected microservices, state typically scoped to the microservice, remote storage for cold data. What are some of the things to get into when you actually start microservices, and what are the tools to deal with monitoring and troubleshooting? First of all, you have detailed system optics. You have the repair suggestions, examples, slow async cancellations, run async failures. All important events are logged. For example, app creation, deployment, upgrade records, all actor method calls. Then you also have custom application tracking, which is basically the fastest standard logging in the industry, ETW. It works across all environments. That same code runs on your dev box and also on production clusters on Azure. It's easy to add, and really system appends to all the needed metadata such as a node, app, service, or partition. And you have a choice of tools. You can use Visual Studio Diagnostics Advanced Viewer, Windows Events Viewer, Windows Azure Diagnostics and Operational Insights, or you can have a plug-in to your traditional tool sets like Elasticsearch or Kibana, etc. And there's a lot of built-in monitoring for your services. So you have visibility into what's going into production. You have performance and stress response. You have really rich metrics for actor and service programming models. You have health status monitoring. Built-in health reports for cluster and system services. You have a lot of flexibility and extensibility on the health store for custom app health reporting. It allows you to have continuous monitoring for real-time alerting and problems in production. And then there's business telemetry. You can collect, analyze, and drive insights from your customers' interactions with your applications. It allows data-driven decision making. Very important on the business side of things. Operations Management Suite is a tool also to manage your microservices environment and understand the health of that. This is obviously simplified guest and workload management anywhere. Service Fabric does have container integration, support for Docker, Windows, and Hyper-V containers to help you with that transition. It runs as running guest containers in Service Fabric is supported. Container does not reference any SF APIs. It uses container guest executable feature, and it also uses the Service Fabric cluster management and resource scheduling capabilities, which really, again, helps with that transition. Building containerized Service Fabric applications. Service Fabric applications, for example, container contains Service Fabric runtime. It builds stateless and stateful Service Fabric services, and it uses Service Fabric cluster management for resource scheduling capabilities. So let's talk a little bit about decision guidance around this topic. There's some new PaaS options with microservices. Let's talk about a couple different scenarios here. A lift and ship front end, small, medium scale, general purpose compute, and that needs Linux support. What would be the solution on that? VM scale sets. And let's say we have containerization microservices and containerized applications on Linux. The solution for that would be Azure Container Services. External websites with minimal guest customization, that would be a web app services. Hyperscale, stateful, and stateless microservices, we obviously know the solution for that. And open source app migration from VMware. You can use tools like Cloud Foundry or even Five9's tool, the V2V converter. And from here you evaluate your app requirements. That's my presentation on microservices. I want to thank everybody for joining MVP Days and listening to my spiel on microservices, introduction to microservices. And to finalize this webinar, I was going to tell you a little bit about Five9 and what I do. As I said, I'm the Director of Product Management at Five9. We basically manage and protect your Microsoft Cloud all in one management plane. We were founded in 2009. We're headquartered in West Palm Beach with a staff in 26 regions worldwide, including 18 MVPs. We have over 100,000 Hyper-V users globally, representing companies and data centers of all sizes. We are the leading solutions provider for security and management applications for Hyper-V, for migration, management, security, and monitoring. If you want to know any more information, visit five9.com or email info@five9 for more information. Again, I want to thank you for joining this MVP Desk session of Introduction to Microservices. My name is Robert Corradini. I'm a Cloud and Data Center MVP, and you can reach me at my address below, or you can hit me on Twitter or read a lot about my blog articles on netwatch.me. Have a good day.